Warning, if you are afraid of bugs, this might not be the episode for you. Just saying. Forests as far as the eye can see. The trees seem to go on to the horizon, providing vast amounts of food. The air is dry, but breathing feels strangely easy. And the wildlife is a lot like your local pond in overdrive. Salamander like amphibians chomp down dragonflies. Except the dragonflies have 2-foot wingspans and their predators are the size of NFL linemen. This is the Carboniferous Period. The Carboniferous spans a time frame from 358.86 to 298.9 million years ago. The name Carboniferous means coal bearing, and indeed, this was when the coal we use today was laid down. Rocks of this age can be found from Siberia to Mississippi. In fact, my home in eastern Pennsylvania is built on Carboniferous rocks. It's tough to characterize the climate for a period of time as long as the Carboniferous in a short video segment, but I'm going to at least give it a try. First off, it was pretty cool overall. The Earth spent much of the period in an ice age, with carbon dioxide levels plummeting and oxygen being absolutely through the roof, as much as 60% higher than today. And the reason for this was simple: the great worldwide forests. Plants take in carbon dioxide to use as fuel in photosynthesis and give off oxygen as a byproduct. And these trees were, dare I say it, tremendous. Some reaching heights over 100 feet. And more to the point, they were everywhere, with woodlands being the number one biome throughout most of the world. Actually, there were so many dead plants that decomposers couldn't possibly devour them all. Instead, many were covered by debris and fossilized into the coal that powered the Industrial Revolution of the 19th century. This combination of sky high oxygen levels and abundant vegetation, coupled with a relative lack of predators, bring about a golden age for one group of invertebrates, the arthropods. Arthropleura might well be the poster child for this age of dominance. At 8 feet long and nearly 2 feet wide, it looks like a walking armored carpet. This thing is actually a monstrous millipede, tramping quite possibly more than 100 legs across forest clearings in search of vegetation to devour. And it was hardly alone in the Carboniferous undergrowth. Meganora was a griffin fly the size of an eagle, the largest organism yet to fly, while Pulmonoscorpius could reach nearly 2.5 feet long. True, these aren't quite the house-sized creepy crawlies of B-movie lore, but they're far larger than anything of their kind around today. To give you an example, the largest millipede alive today tops out around half a pound, 1/2 of 1% of Arthropleura's size. But how did increased oxygen lead to such big, bad bugs? The answer lies in the differences in respiration between arthropods and vertebrates. Obviously, terrestrial vertebrates take in air through the nose and mouth, pass it down the windpipe, and into the lungs for transport via the circulatory system. Arthropods don't do it that way. Instead, they have a bunch of small openings in their bodies, called spiracles, that allow for direct gas exchange. But let's see what happens when you scale this system up. If you double the length of an arthropod, you're multiplying the surface area of the spiracles by 2 squared, or 4. So far, so good. However, you're also increasing the tissue volume that needs to be oxygenated by a factor of 2 cubed, or 8. Similar factors with our muscle cells are one of many reasons why we don't grow to be 30 feet tall. In short, oxygenation levels are the main limiting factor in arthropod size. But in the Carboniferous, that limit was greatly increased. That's not to say that they had things all their own way. Vertebrates were taking full advantage of the good air as well. Eriops was more than 300 pounds of amphibian that haunted freshwater shorelines, feeding on fish and other amphibians. Adults would have spent most of their time on land, but they couldn't truly escape the water. They still needed it to breed. After all, amphibian eggs to this day need to be kept wet, or they'll dry out. They can't be laid on land. Yet one group of animals was finally about to free itself from their aquatic shackles. Hylonomus lived about 315 million years ago in what is today Nova Scotia, Canada. In fact, it's the official provincial fossil. At only 8 inches long, it could fit comfortably in your cupped hands, but its evolutionary impact would prove to be gigantic. This is because Hylonomus was the first amniote, the great revolution of the Carboniferous. Its eggs contain pouches of fluid protected by an impermeable shell, basically a private pond for the developing animal. This would allow amniotes to spread across the ancient world, eventually leading to the reptiles, birds, and mammals we know and love today. And I think that's all for this video. Don't forget to like and subscribe. I've got some subscriber milestone rewards I'm planning. Sign up on Patreon and mention some paleontology topics you want to see me tackle in the comments. I'd love to hear your feedback and get some ideas for future videos. Hope to see you in the next one!